Okay? Since these are all the same, I'm going to take this root right here. This really means it's x equals 7 and x equals 2. Because since they're roots, they are also called solutions. So instead of just saying the roots are 7 and 2, I'm saying the solutions are x equals 7 and x equals 2. Now, without a good explanation why, we'll get into that in just a second. What I want to do is I want to make both of these, instead of saying equals a number, I want them to both say equals 0. How can I make this guy right here go away and equal 0? Subtract 7, right? So I'm going to get x minus 7 equals 0. And the same thing over here. It's going to be x minus 2 equals 0. Okay? Now again, I'll explain it later, but what I want to do at this point is I want to check something. I want to take these two pieces right here, and I'm going to multiply them together. And that's going to give me this, x minus 7. Oh, that's very ugly. X minus 7 equals 0. Oh, no. Sorry. X minus 7 times x minus 2 equals 0. Now, I've got two binomials. I'm going to multiply them. I should be able to do this without showing too much work. What's x times x? And then minus 2x minus 7x is really minus 9x plus 14 equals 0. And what I hope you can see at this point is that these two roots came from this quadratic equation. So what I did was I was able to actually develop the equation that must produce these two roots. Does that make sense? All right, do it again. Same idea. I guess it doesn't really matter. Let's do the fraction. No, let's do this guy. All right. If I know my two roots are negative 3 and 5, then what are my solutions?
X plus 3 0.
Okay. You're right, and I knew you just went ahead and skipped ahead to the next step. But my two solutions are x equals negative 3 and equals 5. And then you went ahead and just skipped to the next step. So that's going to give me x plus 3 equals 0, perfectly fine, and x minus 5 equals 0. Notice the signs. Do you notice how this sign here is the opposite? That's not, yeah, that's a negative.
Yeah.
Good. Do you notice how this sign here is the opposite of that one, and this sign is the opposite of that one? All right, keep that in mind. That'll help you a lot with shortcuts later. Okay? And then take these two and multiply them, and that gives you x plus 3 times x minus 5, and that is straight from Math 1. And you get x squared minus, what is that, minus 8, minus 2x, thanks, and then minus 15 equals 0. Let's deal with this guy. X equals 8, right? That'd be the solution. How am I supposed to write a quadratic from that?
Wouldn't another one be
0?
0?
It's a good idea. It's not right, though. It's not 0. What did I call it when we had it touches in one spot and you only had one answer, it was one solution, but I said it was a special name. It was called a double root. Remember I called it a double root? Yeah, it's x equals 8 and x equals 8. It happens twice. It's a double root. If you only write it down one time, if it only looks like one answer, then the reality is there are two answers. Remember, can you tell me right now what this quadratic would look like? It would go down and just barely touch the x-axis how many times? Once. It'd just touch it once, and we call that a double root. So now that I know I have two of these, I do everything else just the same. So it's going to be x minus 8 and x minus 8. And that is x minus 8 times x minus 8, which is x squared minus 16x plus 64. All right? Double root, guys, double root. Don't forget about the double root. All right. I know you're already here, right? I know you've already done this much. I know you've already told me that it's plus 2 equals 0, and I bet you've told me that it's minus 3/4 equals 0, right? But we don't want to go this way, okay? Now, if I were you, I'd stop writing this down, and let's just play around with it for a minute and figure out why I don't want to go this way. So let's watch. If I were to do it this way, then I would have x minus 3/4 times x plus 2, and I would do my FOIL method, right? And I would end up, right now, I'm already nervous. Are you nervous? Do we often use quadratics with that fraction on the inside? Not very often. So this guy right here is really bothering me. But I'm just going to plug through it, figure out what happens. Let's see, I'd have x squared. Oh my goodness, let's see. 2x minus 3/4 x is plus 1 and 1/4 x. I guess I should do that as a... So that'd be plus 5/4 x minus 3/4 x. Am I doing this right? No. So that'd be, what's that, plus 1.5? Is that right? 3/2? 6 over, yeah. Minus, sorry, minus. All right. In any case, no matter how you slice it, whether I did my arithmetic right or wrong, this is ugly, right? Is this ugly? Ugly, ugly. I don't like ugly. You don't like ugly? All right, let's make it pretty. This is not the best way of doing this. So instead of doing that, I'm told you not to write that down. We're not going to do it this way. What we're going to do is we're going to figure out a different way to handle this fraction, okay? What is it that's bothering us about this whole problem anyways? What is this thing? How do you get rid of fractions? You can always get rid of fractions by multiplying by the denominator, right? So get 4x equals, what's 3/4 times 4? It's just plain old 3, isn't it? Don't those go away? Hey, isn't that a lot easier than what we had with the fraction? So now make it say equals 0. 4x minus 3 equals 0. Is this prettier? I think it is. This guy is much, much better. Now let's multiply them out. Does this look more in line with what you're accustomed to doing? Having all integers up here? Yeah, that looks better, doesn't it? So now we can multiply, and that's going to give me 4x squared. Let's see, plus 8x minus 3x is plus 5x and minus 6. Question for me. What is 5 times something equals 0? What has to go in that box? Everybody agree it has to be 0? All right. So if I did it again, what about 274 times something equals 0? What has to go in the box? It has to be a 0. Okay? Now here's the final question. If I take something times something else and get 0, what has to be in the box? All right, I heard it from a couple of you. You said one of these two must be 0. Does it matter which one? Could it be both? Could be, but at least one of these has to be 0. And that is the zero product property. One of these must be 0. That's the zero product property. Okay? And that is why we did exactly what we did on that last page. Remember I kept telling you to make them equal to 0? That's why, is because I was trying to force you to use the zero product property. I just didn't tell you what it was. So basically what we want to do is look right here. Is this example that they gave me an example of the zero product property? Yeah, look, instead of you thinking about those as parentheses, think about them as those two boxes I just drew. Something in this box times something in this box has to equal 0. What does that tell me about these two boxes? One of those two boxes is equal to 0, so that's what they said here, and that's what they said here, and that's what we're going to do, guys. We're going to factor. So I want you to take this right here, and let's factor it, and that should be an easy one. You got x and x. What's the other two? What can you multiply to give you negative 45 that will also add to give you 4? What's that? All right, there we go. So it's negative 9 and positive 5. All right. Well, right here, did I do that backwards? I sure did, didn't I? Positive 9 and negative 5. All right. So the zero product property tells me that one of these two must be 0. So one of these two must be 0. So I simply say x plus 9 equals 0. X minus 5 equals 0. Which one of those is equal to 0? Well, depends what x is. When is x? If x is negative 9, this one's equal to 0. And if x is positive 5, the other one's equal to 0. So what are your two solutions? All right. So now you know that this quadratic will cross the x-axis at negative 9 and positive 5. All right? That's the zero product property. That's how you solve by factoring. Yeah, I can't use the zero product property unless it says equals 0, right? So I got to have 5x squared minus 15x equals 0. How do I factor this? GCF, good. 5x and x minus 3 equals 0. Now some people miss this. Is this the same concept as these two boxes up here? Sure it is. Even though it's not two binomials, it's still two numbers that are being multiplied to give you 0. So one of those numbers must be 0. So I'm going to solve things exactly the same way. I know that either 5x equals 0 or x minus 3 equals 0. And those are both easy to solve. What does this tell me? X is equal to 0, right? Because 0 divided by 5. And then this one would be x equals 3. All right. Hey, somebody said it. All right. After I make it equal to 0, it does have a GCF in it. So I'm going to take a 5 out. And that leaves me with 2x squared plus 5x minus 3 equals 0. That's a minus. And now what do I got to deal with? Okay, I do. Good. Some y'all remember these are the harder ones to factor, but 2 times negative 3 is negative 6. I'm just going to use a little scratch paper right here, negative 6. How can I get negative 6 and then still get 5 here? Multiply to get negative 6, but still get 5 here. It's got to be a 2 and a 3. Are you sure? Because this is a negative 6. That one won't work. It's going to have to be a 6 and a 1, right? Positive 6, negative 1? All right, so that's what I'm going to have to do. This one I'm actually going to do by grouping. So 2x squared plus 6x minus 1x minus 3. All of that. Oh, wait, that's just the inside, isn't it? I still have a 5 right here equals 0. So this is a little bit awkward because I'm trying to do two things at once, but here I'm trying to do by grouping. So what are my two groups? Okay, that's one group, and then here's the other group. So let's just do one group at a time. This would be, let's see, what do they have in common? 2x, and that leaves me with x plus 3. Does that sound right? And the other group, what do I have? What do they have in common? Oh, be careful. Oh, somebody figured. Yeah. they actually do have a negative 1 in common. They're both negative, aren't they? And remember, everything always has a 1 in common. With these both being negative, if I take out a negative 1, that'll force it back to positive like I'm looking for. So they have a negative 1 in common with an x plus 3. Okay? And now, actually, all of that is still in its own parenthesis, and I still have a 5 there. Can't lose that 5. And it's still equal to 0. I'm out of room on the side, but it's still equal to 0. So that gives me 5 parentheses, 2x minus 1, parentheses, x plus 3. That's my factor. Now that gives me how many terms am I multiplying? 1, 2, 3. I'm multiplying 3 different boxes and getting a 0. What does that tell me? One of those boxes is a 0. So I ask you, is it the first box? Does 5 equal 0? No, can't happen, can it? Can 2x minus 1 equal 0? Sure it can. When does that happen? Whenever x equals, let's see, think, you got to add 1 to both sides and then divide by 2.
1/2.
Be 1/2. And can x plus 3 equal 0? That happens when x is negative 3, right? So I totally ran out of room, guys, and I'm sorry about that. But this, when you take out a GCF, if it's a constant GCF, it just basically disappears. Remember I mentioned that on the problem on the other page. You know, that just makes it 5 times steeper, doesn't it? But it's still crossing at these 2 points. So those are my 2 solutions. First thing I ask you is this. What is her current area? What's the current area of her garden? Somebody said it. It was 24. And you got that from doing 6 times 4. You got 24, right? Okay. What does she want it to be? She wants it to be double. So what would it be? 48. All right. I don't have to show a lot of math for that. She wants it to be 48. Now, how is she going to force it to be 48? She's trying to do what? Add the same amount to each side. Well, how much is that? Do we know?
No.
Is this algebra?
X.
Yeah, that's our x. She wants 6 plus x here and 4 plus x down here. I don't know how much to add, but I know it has to be the same, so I have to use the same variable. Well, how would you find the area if I know the length and the width? Multiply them. So let's multiply 6 plus x times 4 plus x. And what do I hope that equals? 48, because she told me she wanted to double it, remember? The old one was 24, the new one has to be 48, so we want this to equal 48. So I just got to multiply, right? Do you mind if I switch the order of this right now? All right, x squared plus 10x plus 24 equals 48, right? Am I ready to solve?
No.
What has to happen here? Okay, that's got to be 0, so I take out the 48, and that gives me x squared plus 10x minus 24 equals 0. And I believe this one is factorable. What multiplies to give you negative 24, but at the same time adds to give you 10? Positive 12 and negative 2. I agree with you. And how do we know what the final answer is? That means x plus 12 equals 0, or x minus 2 equals 0, right? So x has to be negative 12, or x has to be positive 2. Now think. This is a word problem. Okay? Negative 12. If I did 6 plus negative 12, how long would this side be? Negative 6. Does that make sense? No. If I did 4 plus negative 12, how high would this side be? Negative 8. Does that make sense? So that tells me that this is out. So what about the 2? If I plug in up here, 6 plus 2 and 4 plus 2, 6. So I've got 8 by 6. Does 8 times 6 give me 48?
Yes.
Sure does. So my answer is right there, and my new dimensions are going to be 8 by 6. All right.